And you ready to get started? Okay, so I took in a mix of the harder questions of stuff we haven't done. Okay, start with this one. What do you think? Yeah. So you can do that. So I think what I'd probably do is like break down O to Y. So like O to Y, how would you get from O to Y? So first go O to C, and then well, let's just say C to Y. And so so O to C was 3C. So then you break down C to Y. What do you mean, sorry? Yeah. Yeah, parallelogram. But even before then, so C to Y, what could you say about that? Yeah, so that's 2A to X. Okay, so now we need A to X. Yeah, so A to B and then B to X, and A to B is 3C as well. Okay, what about B to X? Now we're at this part. Yeah. Yeah. So that's going to be b2x is 6a. And now simplify. That's it. Oh, for whatever reason, I was right the other way around. Okay. Yeah, so basically break it down into its bits. So O to Y is O to C plus C to Y. C to Y is A to X. A to X is A to B plus B to X. And you just slowly break it down. Any questions there? No, you don't need to know its position. So find in terms of A and C the vector O to Y. Yeah, so that's in terms of A and C. That's O to Y. Okay, how about this? Yeah. So that would be the opposite. So something 5 times gave you 32. This is the probability of 5 heads. It's not divided by 5. When you think about probability, like what's the probability of getting heads 3 times on a coin? How do you do it? Yes. And so that's the same as a half to the power of 3. It's not a half times 3, because then that would be more than 1. So then how would you work backwards? So let's say if it wasn't a half, it was x to the power of 3, and that gave you something. No. How would you calculate it? That's it. So you'd have to cube root instead of divide by 3. So that's just for example. So then how about this one here? Yeah. And then yeah, 5th root they call it. Okay, go for it. Two fifths? Okay. X 2/5. Okay. What next? Yeah. We didn't times this one by 3 or times this one by 5. Yeah. Okay. And then? So that's 4 heads. Well, what's the probability of getting a tails? Yeah. And so what do you do there? If you were adding them, then that would be for either or. They get either a head or a tail, so it would increase their chances. And yeah, you times them because it's both 4 heads and a tail. That's it. And what do you get? 1,325. Yeah. Oh, so it's just 48 over that thing. Then, all right. 3, 1, 2, 5. Oh yeah, that makes sense. Okay. Any questions there? Okay, so instead of divide by 5, it's 5th root, and then you go from there. So this one, maybe we don't really need to do it. Draw a histogram, because actually when I looked at our stuff, we recently did a histogram thing. Do you know how to draw a histogram? Okay. Okay, how about this? Okay, why would you do that? So it would be easier if on the top one you made it either y equals or x equals. Yeah. And then what could you do? No. So remember you were saying you could make it like squared. So you'd square both of those. So you now have y squared. No. So y squared is equal to 3 minus 2x squared. So you can, instead of having y squared here, you can sub that in there because they're the same. Yes, and so now you've gone from having 2 equations with 2 unknowns to having just 1 equation with 1 unknown, so you can solve that. Yeah. Well done. It's 12x plus 9. Okay. I'd mistake the 18 to the other side. Yeah. 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 Okay. Anything else? Because I don't think they can make 12. Okay. Hang on. So this minus 12x you can write as plus 3x minus 15x. Okay. Yeah. What are you factorizing? So factorize the first two separately. Yeah. Yeah. So you need the same bracket twice. So we'll go on the outside. So you need the same bracket twice. So what would you have to factorize out to get 5x plus 3 in a bracket? Yeah. Yeah. Okay. Fully factorize. It's just 5x plus 3. And then the other bracket is the other 2. Yeah. 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 Is that full marks? Yeah. And so what might be easier is we already have a y equals the 3 minus 2x. So what would that be? Yeah. Yeah, I'll just put it in your calculator. Oh, there you go. 21 over 5 or 4.2. I'll do 21 over 5. That's it. Okay, any questions there? Let's see. So the way you can do like simultaneous equations either by elimination or substitution. So when they're both xy, elimination is common. For if you've got something squared, then you have to do substitution. And the way you do it is the simpler one. You make it either x equals or y equals, and then you square both sides so that you can get x squared or y squared. And then whatever that's equal to, you sub that into the other equation instead of the x squared or y squared. And that way, instead of having x's and y's, you go to have just x's. And then you just solve that, and then you use your two answers to get the other one. It's tricky. Okay, yeah. So this is going to be a tricky one. Let's try this. Nothing. It's just a number you have to find. It's like x. Oh yeah, so okay, so that would give you, an estimate for it. The thing is, so these numbers are rounded. It was 6.8 to 1 decimal place, 9.2 to 1 decimal place. They want you to find the lower bound for the surface area. Any idea about that? Well done. So then that's 6.75. Yep. I don't think so. I think that because they rounded 6.8, so the lowest that could have been was 6.75, and so I think you just stick with that. Yeah. Okay. Yeah. And they want it. Or no, go on. 97.0, is that it? Yeah, so they want it in terms of pi. So I suppose you could just do these 2 times and see what that is. Or divide it by pi, same thing. Yes, 30.9 pi. So k is 30.9. That's it. Any questions there? Okay, so that's all right. So that was 4 marks. So I didn't take in anything that was less than 3 marks. So, or yeah, that was 3 marks or less. I just went for 4 more. So that's all right. And they're all at the end of the paper. I think it's because we did bounds that you have it already fresh. Okay, how about this? I don't think 125 over 27 will simplify. And how would you do it? What do you mean the 25th? I'd probably do it. So what is to the power of a minus? What does that do? It does something to the fraction. Yeah. And in terms of a fraction, what is that? So if you had something like 3 to the minus 1, that makes it 1 over 3. And that's because 3 by itself is the same as 3 over 1. So what will it do to a fraction? Yeah. So what will it become then? Yeah. Yes, and so that used up the minus. Okay. Okay, how do you do that? Yes, okay. Okay. Well, what is 2/3 times 3? Yep. So that's 9. What? Yeah. Okay. How about the bottom? Mm-hmm. That's it. Okay, you got it. Yeah, so I've never seen someone entirely use a calculator like that, but yeah, it worked. So it's basically the 3 is the cube root because it's the denominator, and then you square it. So the cube root of 125 is 5, and then 5 squared is 25. So that's why that worked out. And yeah, you're just multiplying the others. So no, fine, that worked. So this one we kind of did something similar, but not quite. Okay, how do we do this? It doesn't matter. Probably you could. Okay, so if you did that, how would you do that, or what would it be? Yeah, okay, that'll work. So how would you simplify it? So you could multiply the 2 in the middle, excuse me, the middle and the last, because they're both to the power, they're both the same base 2. So that's 4n. So you copy the base, so that'll still be 2, and that'll be n over 6, yeah. So you just copy the base and add the powers. No, you add the powers, don't you? Yes, you don't multiply the powers. So that would be n over 3 plus a half, not times a half. You could do that, yeah. That's it. Let's write like that. Okay. What's next? Remember how you could multiply these two because they're both a base 2? Make everything 2 to the power something. Yeah. So let's say 2 squared. 4 is 2 squared. And then how could you simplify that? So what's the rule for power to a power? And so 2 times n. Yep. So what can you do there? What's the rule for multiplying indices? How did you do it up here? Yeah. Yeah. So yeah. Oh. Yeah. Yep. And remember that whole thing, so now that whole thing was equal to 8 to the power of x. So what do you do there? No. Remember the way we've been able to do this is that we made it as 2 to the power of something. Yeah. And so how would you write that? Yes. Can you simplify it? That's it. 2 to the 3x. Okay. And so basically, you see how this is 2 to the power of something is equal to 2 to the power of something else? So what you know about those two powers then? Yeah. Yep. And might be easier. Divided by 3 is the same as times a third. So what would that be? No. Times the tops, times the bottoms. So you're multiplying by a fraction, so top times top, bottom times bottom. Yeah. That's it. So that's what they wanted to express x, so x equals in terms of n, so n will be in your answer. So the big picture is you have to make everything 2 to the power of something. That's like the lowest common denominator type of thing, the lowest common base. So make everything 2 to the power of something so that you can bring them together. Keep doing that even though it's very complicated, and then you get to a point where it's 2 to the power of something is equal to 2 to the power of something else, and then you can just say, well, those two powers must be equal to each other, and then you go from there. Yep. Any questions about that? So long and complicated. This was on the paper that I was looking at. Is this something you've been doing in school? Okay, so this is the part B was the important bit. Hang on, I think I'll need part A as well. So how do we do this then? You might have to do part A to do part B. Yeah. Mm-hmm. So this dy dx is it gives you a formula for finding the gradient at a point. And so basically there's some value of x that when you sub it into that, you get minus 27 over 2. And so how could you find that value? There's a way you can calculate it. So some value of x, when you put it in for x, gives you minus 27 over 2. Make them equal. And then try to solve it. So how would you go about this? You could times times everything by 2. Yeah. Equals. Yeah. And then. So what type of equation is it? Yeah. And then? So is there some number that they'll all divide evenly by? Make it a bit easier. Yeah. And so what would that be? Nine equals 0. And then you would solve that. Mm-hmm. So just do them. 3 and 12. Okay. Yeah. That works. Yeah. Actually, you can take out another factor. What else do they have in common? Yeah. So that goes in the bracket there. Yeah. Mm-hmm. Mm-hmm. There you go. Equals 0. Yeah. Yeah. Right, it's 3 over 2. And what is... okay, so they asked us find the coordinates of P. Is that the coordinates of P? How do you do that? If only the question gave us a nice formula for finding y. Even simpler than that. What? Yeah. So what do you do with that? Yeah, and it's probably easier to use 1.5 in a calculator actually. 1.5. So you write down what you're doing. That's the method, and then just sub it in. Get the answer to 1.5 cubed minus 9 1.5 7. There you go, quarter. And so what's the coordinates of P? Oh, did I forget squared? I did forget. Minus 13 over 2. Yeah. So minus 13 over 2. So if you're going to do 1 as a decimal, do both those decimals. It's minus 6.5. There you go. Yeah, so dy dx is a formula for finding the gradient at a point. They said the gradient at a point is minus 27 over 2. So there's some value of x that gives you that. So make them equal to each other. Solve to get that. So it turns out there was only one value, which was 1.5. And then sub that in to get the y value. Any questions there? Okay, so yeah, quadratics comes up a lot. Okay, let's see. So this one, how do we do this type of vectors question? Mm-hmm. Yeah, I think those first three lines were the most important thing. Like OY is this and this, CY is 2AX, and then AX is A to B plus B to X. And then so that's kind of the big idea for that one. Okay, how do we do this one? And why? Why do you fifth root it? Yeah, so you don't divide by 5, because if you think about it, if you had, 2/5 or something like that, and you times it by 5, then it'll be more than 1. So you're always squaring it, cubing it. And so to work backwards, you do square root, cube root, fifth root. Yes. And then it was just times by, to the power of 4, and then times by 3 over 5. To get that, you do 1 minus the other one. So this one was all right. Okay, how do we solve quadratic simultaneous equations? Yeah, then you just solve it, and then with your answer, sub it back in to get y. This one you're all right for, I think. You just have to look it up on the formula sheet. And yeah, lower bound, so that's the lowest thing it could be. Okay, how did we do this one? Yeah. Mm-hmm. Yeah. Yeah. So you made sure work it out. Okay, how about this one? Yeah, so get the bases the same. It's like common denominator, so that you can combine the two. And then this was kind of the important moment where you finally have it as two to, like one thing, 2 to the power something and 2 to the power something else, so they must be the same. So like that's why we had 3 different things and we had to break them down to just one, so we could do that. And then how did we do this one? And why did we make them equal to each other? Why are they equal to each other? It's basically because there's some x coordinate that when you put it into that, you get minus 27 over 2. So we could have guessed. We could have done like try 1, try 2, and you'd notice that's too small, that's too big. I thought there'd be 2 answers, and so it'd be too difficult to do it that way. But then actually, yeah, so 6, this, so some value for x, you put it into this, and you get minus 27 over 2. And so the way to actually calculate it is, well, that 6x squared minus 18x is equal to minus 27 over 2. And then you just figure out what the x is, that gives you that. And so that's why those are equal to each other. Yeah, and dy dx is a formula for finding the gradient at a point, and the gradient at the point was minus 27 over 2. So that one gives you that. Yeah, how was that for you, Andrey? Yeah, it's good. So I'm leaving out some of the questions because they're kind of the same. They you know, they come up a lot where they kind of save it for the last question and all that. Do you want to continue this next time? All right. Any questions for me in general? Okay. Well done, Andrey. You're doing great. I look forward to talking again next time. Goodbye.